So this is Von Sink, Lucinda Garcia, and Ben Simmons, and we're going to be presenting evolutionary theory. So the origin of life has been a speculated thing for much of human history. More traditional answers to how life originated is typically found through supernatural deities spawning everything, or life just spontaneously being created from nothing. Well, the empirical answer to this is found in evolutionary theory. However, we wanted to investigate why it is held as a credible theory just in modern science. So our research question is, why does modern evolutionary theory have wide credence as opposed to other postulated origins? So we found that it gains this credence due to the evidence that it provides and how it exists throughout various fields. It additionally adheres to a scientific process, so it's not just being created from nothing. So as to how it actually came to be, there was Charles Darwin and Alfred Russel Wallace. They came up with the theory around the same time. However, Darwin gets credit for it just because he had started investigating it first. So it essentially describes life as sort of like a tree, with each branch being a different pathway that a genetic lineage of an organism would take. So the traditional evidence was found through basically similarities in the body parts of different organisms and the functions that they served. However, new evidence for evolutionary theory is mostly present through analysis of DNA.
One clear representation of change over time is through the fossil record. A fossil is essentially just the remains of an organism cast into rock after it's died. This could be through lava or at the bottom of a lake, things like that. The further down you go, the more simple the organisms become. We believe that this shows that things have evolved from single-celled organisms to multicellular intellectual things that we have today. Throughout these levels specifically is the presence of what's called a transitional organism. These are organisms that aren't quite one thing and aren't quite another. There aren't very many of them, but the presence of one really shows that they do exist. And these transitional organisms arise from adaptations. Now, adaptations is what happens when certain organisms in a species are born and they are different, or they have something odd about them, but it actually makes them more suited to their environment. This makes them more likely to produce, passing their genotypes on to the next generation. The genotypes are the way genes are arranged within an organism, and their phenotype is how they're presented as traits, how things look, how they act, how their body is molded. This leads to natural selection, which occurs based on fitness. Again, like I said, what is better suited to the environment around them. Throughout time, certain characteristics become more distinct, such as the Arctic fox and the red fox. Obviously, the Arctic fox is more suited for winter, throughout the cold, snow, and the red fox is more suited to fall, forest regions. This is similar in humans in that humans have different color hair, skin tone, eyes, things like that throughout where they have been dispersed within their environment and how they reproduce. But both adaptation and the fossil record lead to a common ancestor. All organisms truly have DNA similarities, which suggests evolution, but more specifically, according to the Smithsonian, the genetic difference between humans and chimpanzees amounts to only 1.2%, which is very, very close. In fact, they state that humans, chimpanzees, and bonobos are more closely related to one another than either of them are to gorillas or other primates. This is to really say that through adaptations and natural selection, primates and humans are the resultant divergence within this common ancestor. Common ancestry is not to say that giraffes became whales. This is to say that giraffes came from one organism that branched off from another organism, from another, and from another, so on and so forth. To steer back to the original point, both the newly evolved humans and the early primates were more likely to survive in their respective environments than this common ancestor. So thus the common ancestor died out, while the humans and the primates went on to live in their own places, their own environments, and reproduce.
So a form of an attribute that humans have, which is connected to a common ancestor or previous environments, it would be like responses to aggression, responses to the desire to reproduce. Like there's many organisms, mainly in the animal kingdom, have a strong desire to reproduce. It is one of the driving factors of evolution, and then it's also the fight or flight response, which it can prolong the life of an animal or a creature. Also, that there is proof that humans once lived in an environment which was similar to a hunter-gatherer environment, and what this shows is that evolution is not a fast-paced process. It is very slow-paced. Like around 10,000 years ago, we only began to start agriculture, and so. But before agriculture, there was hunter-gathering, and there was very little fats, very little nutrients in our diets. But we had a strong desire because those were beneficial to ourselves. But now, as we see in today's modern times, where we have mass agriculture, lots of food to go around, it has become a problem, and humans cannot. It is much harder for us to maintain a healthy lifestyle. Another way the environment has changed humans is by the development of modular thinking, which is modular thinking is like it's the separation of the brain processes into different groups and categories, into like mathematics or critical thinking or decision making and communication. What modular thinking does is it provides a much more efficient, much faster and more accurate way of perceiving the environment and making a good decision in order to help reproduce and to prolong the life of the animal. So while evolution doesn't explain all the aspects of life, it provides a very good theory overall of how we came to where we are today. What it does is it helps show the so it just evolution is like it helps show where we have come, and I think that that as we continue to get better in science, the science fields, we will we'll fill in the many gaps within evolution. But I think it's a much more viable viable claim than something that is completely conjured up through faith.
Okay, let's jump into the questions. Question number 1. In what way did you improve your ability to work with a group as a result of this project?
I was able to improve my ability by bouncing off ideas, and one person would give a point, and then it would bring something into my mind which I could apply to my own lens and view of
Okay. Who's next? In the future, what change would you make to your group's norms, so how you'll interact with one another? And how would you expect that to improve the team presentation?
Towards the end, we would actually call each other and present out loud, and I think it would have been more beneficial to us if we had done these phone calls from the beginning, because it's easier to bounce ideas off of each other and to have a flowing conversation that leads to other ideas through talking instead of just messages or notes and things like that.
Okay. What is a way in which your team's resolution makes you think differently about your own individual research?
So, I feel as if our resolution was more or less the same. So there was very little change between my research and the resolution of the group. It's just that mine went into more of a historical sort of focus on the theory.
Okay.